So, very welcome everyone. My name is Magnuz Engardt. I will be your host today. And today we will have the pleasure of listening to Robert Kautsky. Robert is from Azote and he will talk to us about communicating research so people can listen and care. And warm welcome to Robert. The Zoom room is yours.
Thank you very much, Magnus. It's a pleasure to be here and talking to you about this topic. And I thought, well, I need to introduce myself in some way. So let's start with the beginning. This is me, 5 years old, examining some blue mussel experiment that my dad was working on. Both my parents were marine biologists, so I grew up in Askö field station and on the west coast of Sweden in the Tjärnö Marine Biological Laboratory. And very early, like in my early teens, I felt so sorry for my parents' students because they had these horrible overhead slides. So I redrew all their lectures. And I continued in my upper teens. I made the compendium of all the marine algae on the Swedish west coast together with my mom. She's working with algae, which is still being used today. And then I founded a company called Azote. We're around 20 people now, and we work with communicating science both within academia, but also to external stakeholders in both in policy and in business. And we're based in Stockholm, in Sveavägen. And we started this together with the handsome guy sitting in the middle there with no hair, Jerker, when we were studying students at the university. He was doing a PhD in systems ecology, and I was doing a PhD in media and communication studies. But I never finished mine because I realized I was much better at running companies and working practically than I was at doing research. But we saw earlier that there's a need for a communications agency that is that knows enough about science so that they don't make mistakes and that are really good at reaching audiences outside of academia. And this is sort of the context we're working in now. We have for a long time mainly been communicating the sort of this list of global crisis in different ways. But we're also doing it very much in a climate of misinformation and disinformation right now, where science is being attacked from many different angles, which is something that has changed the conditions a lot for how to communicate effectively. Azote was lucky that we started working with Stockholm Resilience Center around when they were founded, and this is a picture of me looking really happy when they inaugurated the new offices 3 years ago, I think it was. It is a 4-meter long wall showcasing all the different theoretical models and sort of the main science output from Stockholm Resilience Center. When we compiled this, we also realized that between Jerker, our illustrator Elsa, and myself, we have made all these illustrations over the years, except for 2 of them, but I'm covering them with my head and my hand. That's why I'm smiling so much. So this wall has, it's a very, I wanted to show it because I think it's a sort of an effective way of communicating research. It sits in the entrance, so it's an immediate impression when you enter their offices. If you're 10 minutes early to a meeting, you grab a cup of coffee and you start reading. And it gives a nice context to all the students and all the researchers that even if they're working on a small subset of this knowledge, this is sort of the base and the foundation that they rest on. Just in the past 2 years, we made so many new illustrations for them that we realized that we would actually need to expand it another 2 meters to fit them in. But we can't do that because then we'll block the hallway. So we will need to rebuild it somehow. This is one of our key illustrations that Jerker has made for the Stockholm Resilience Center together with Johan Rockström and team, the planetary boundaries figure. This version showing the impact of the food system contribution is being discussed in the Japanese parliament this week. And it has really gotten a global distribution. I think it's something that's interesting to reflect on is when we make illustrations that sort of get a life on their own. What do they convey that hasn't been visualized before? In this way, in this illustration, why it's so effective, we are also seeing that a lot of companies are now using the planetary boundaries as a basis for their own sustainability and transformation strategies, is that it shows many things at the same time. It's not just the climate crisis, not just the biodiversity crisis, but actually 9 different important aspects to consider. Another type of illustrations that we do a lot that communicate complexity in an effective way are these types of icon sets. We made a toolbox called the Resilience Science Must Knows, showcasing the 9 key aspects of resilience theory that is applicable and important for all decision makers to know of. This is a third type of illustration I wanted to show. It's the type of illustration that shows sort of what we bring. Most people have a very vague understanding of what polar Arctic research consists of. In this case, we just made a nice visual showing the actual measurements that were made, the technologies on the site, etc. Oftentimes, I think when communicating research, many researchers sort of jump too fast into the details, and we forget to show the overarching picture of the actual sites where we are and the actual tools that we use. What is good in any type of illustration is that we only have exactly the details that you want to show. You can scale away everything else. This is a different example I wanted to show. We do a lot of illustrations for applications of different kinds. This is the application for the plate program at SLU and Stockholm Resilience Center that was later funded. And it's strategically smart because when reviewers are reading maybe 100 different applications, it's often the visual impact that makes it stand out and be remembered. And if you have a well-structured visual presentation and well-written text, you often differentiate yourself from many others that only focus on the text and maybe do not focus as much on the imagery. And finally, I thought this is an example. It's from the Kautsky project in the Baltic Sea. It's the type of illustration where you can talk to it for 30 seconds and say something that in a healthy coastal ecosystem, we have gas fluxes that store a lot of carbon into the ecosystem, whereas if it's degraded, we have a release of climate gases. But you can also talk to the same illustration for 30 minutes. And we see that producing this type of illustrations is a really nice complement to texts and other types of communication, because it's something that people can remember. Even if you zoom out of this picture so that you only see it in a very tiny size, only see the colors, it's something that will, in a way, it can work as a mental coat hanger in the head, so that the information has something to stick onto. Again, you can highlight as many or as few details as you want in it, and you can build it up with different layers. We also do illustrations of complex things that you cannot see. I mean, if the previous was an example of illustrating the different flows in the natural system, we often have to communicate things like worldviews, methodology, policy processes, decision processes. This is an area where you can't really take a photo of it. If you think of it and of visualizing it through photography, it's usually inadequate. whereas you can make illustrations that really bring a point. With my current work, I've just started as at a foundation called Voice of the Ocean Foundation that work with ocean science and ocean literacy. We have, for the past 3.5 years, produced an IMAX movie that will premiere now in June. And this is in essence, it is research communication, even if you don't immediately think of it that way. By producing this immersive 3D experience like in Cosmonova and these dome theaters, you can actually create a feeling in the viewers that would otherwise be very difficult to have. Most people don't go have the possibility to go diving with whales, but you can come very close to that experience through this type of medium. And the Ocean Dreams film is a really strong emotional story about how quickly the ecosystems in the oceans can recover if we let them. So they have produced these films from really fantastic places like the Bikini Atolls that were devastated by the atom bombs, but are now really diverse coral reef ecosystems again. I also wanted to show you this example, which we did for a few years ago at Skansen in Stockholm. We had been building exhibitions for them before, and they wanted to transform their escalator going up to the Soliden stage, where Allsång is produced, into a biodiversity exhibition. The thing was that they had started, like they always do, with having workshops with researchers. So they had produced a lot of information that they wanted to portray, and the vision was to have a movie with a narrator and sort of really pack it with biodiversity. But our early insights showed that most people, they don't have a relationship to the word biodiversity, biologisk mångfald in Swedish. They don't know what it is. So we realized that we have to start with a feeling. And we created a 40-meter long transect of all Swedish environments, where you start below the surface on the west coast of Sweden, and you end up in the Northern Lights in the north. And you move through the ocean, through the forest and wetlands, gradually into more and more visually sort of anthropogenic environments, where you sort of the agricultural system, etc., and then the city, and then into the mountain range. And it's filled with these animals. It's the music was composed with an orchestra, and different instruments make the sounds of the different animals that you pass as you go in the escalator. And what happens is that as soon as you come in there, you start watching it, and the kids, they point to the screen and they ask their parents, "What is that?" And the parent starts to tell the children, "Well, it's a lynx. We actually have these big cats in the forest in Sweden." So they engage in a conversation about what they see on the way up. And once they reach the top of the stairs, they are presented with recent current environmental data and two stories. One projection about all the problems in the world, and one projections of all the necessary solutions that we already have to these problems. And this, it turned out it works really well, and there are roughly 1.2 to 1.4 million people that pass through this exhibition every year. But I think it's the main lesson here is to not overload your audience with too much details, but instead letting them explore it on their own terms. So to sum up this, the brief expose of visual communication you just had, this is often the first impression that people get of your research. When when in studies, when we see how we look at a document or a report, we often look at the figure first, then read the figure caption, then read the title, and then read the first paragraph. So how we present ourselves or our communication, our research visually is key. And my advice is to try to make it stand out as much as possible in order to spark that curiosity. Because if someone becomes curious, they sort of solve everything on their own. But if you try to force it on them, very little will happen. And in order to do this, to understand how you can spark the curiosity, it's important to imagine your audience. How can we connect with this specific audience in a meaningful way? And finally, I wanted to say, try to make it easy to copy and use. Of all the illustrations, all the visuals that Azote has produced for the past 20 years, we've always tried to spread it with Creative Commons or sort of open licenses, and this works. The best result is when someone steals it and wants to use it. So I would really like to encourage that. But we're sort of also at the brink of something new. We have AI now. It's something that has affected us a lot in the past few years, and I think it will affect us a lot even more, especially when it comes to research communication. So I wanted to show you a quick example, and then I'll jump back into this. Let's see if you see it. This is a system I'm building together with Oskar Nyberg, a researcher at the Bayer Institute and Royal Academy of Sciences, who specialize in aquaculture and antimicrobial resistance. And the task was to see what knowledge is available and how can we get access to it. So we have programmed the system where it currently holds all the published metadata on all published papers on antimicrobial resistance. It's about 260,588 papers in total. And it has a backend system that is fully automated, so that this report says it's harvested 455 new publications in the past week. So what Oskar can do here is that he can search for something. I think this is it's some kind of antimicrobial term, and he can see how many publications that exist from 1990 and onwards using this search term. And of course, he can make much more advanced searches. And once he's happy with the data that he wants to collect, he can create a collection from it. I won't start that now because it takes a couple of hours to gather all the data in full text, and it costs a few hundred kronas to run it. But we can look at one example here. For instance, he made the survey around some kind of genes related to antimicrobial resistance, where it found 875 papers, and 700 of these were gathered in full text. He has all the papers here, so he can search for things he wants, or just expand them, or go directly to read them. And he can also create. He gets an overview of sort of which pathogens have been analyzed or which species are involved. And he can create different types of synthesis, like what kind of research gaps exist, etc. So switching back now to the presentation, and here we are. So what does this mean if we suddenly have access to everything? in a completely new way. Well, Azote has always been producing nice reports like these ones. And I think we'll go from making those types of report to making all the underlying knowledge accessible as well. For instance, in the Stockholm Resilience Annual Report, I mean, it's a really good example of a nice report. At least the 20 or so pages at the end, they have hundreds of references, all the published works that has been created over the year. So one question is, can we make all that research more available? And the method that we are working on typically is called retrieval augmented generation, or RAG architectures. It's basically an AI chatbot that only has a specific knowledge from a curated collection of data, like in the example of Oscar's antibiotics site. We specify exactly what type of reports or data should we put into it. And it has very strict delimitations on what to answer and where to say, I don't know that. I'm not trained on this topic. I can only answer these types of questions. But it's a way of making something that's truly curiosity driven, because it adapts to the audience on an individual level. When we make the printed report, we have to imagine the policy maker or the business leader or the science colleague who is the reader, and adapt it to just one type or a few types of readers. So it's always a guesswork on how to get them interested. Whereas in this type of structures, we can start with the question, what do you want to know? And they can start to explore the knowledge from that perspective. And we can also build in layers that work very well as a mentor or a guide, so that they lead you further into deeper knowledge while still remaining a relevant context that has been set by the designer of the RAG. So what I'm thinking, and is I hope is a good question to start our discussions after my presentation, is that 2026 is really the year of these new knowledge infrastructures. And it's you, researchers, who know where the boundaries of the field actually are, because the RAG will only be honest if the source selection is good. One risk is that AIs are always very eager to please. So if we have systems like there currently in a lot of companies are being built by the marketing and the tech teams, they will just favor the interests of whoever commissioned them. And I think this is really 2026 is the year when we will go from everyone experimenting with AI to actually seeing this type of infrastructure being built. And this is a window now for shaping how research is represented inside these systems. And one risk I see is that if it's not the researchers that lead this, we will get much more divergence. The big actors, they are already investing heavily in AI, and they will get their own AI that look after their interests. And the small actors, they will get left behind. And if we think that knowledge, to some extent at least, is important for systems transformation, then now is when we have the time to democratize access to research. And it's a very concrete thing to do. We can, by building this type of knowledge architectures, we can provide the same information to all actors in the system at the same time. And this is something I think will be of big value. That's my presentation for today. Let's talk.